And welcome to Module 15, Onward and Upward. So let's start talking about some costs and some of the concepts that go with that. So if we're looking at costs associated with what we're doing, we have our cost drivers, and we're going to look at three broad categories. Now, we'll talk about materials, labor, and overhead later. But right now, we're going to talk about variable costs, fixed costs, and mixed costs. Those are the three broad categories we want to get a handle on. And we'll do a deeper dive into variable, which is one-to-one. If I'm making a car, I need one battery. I might need 4 seats and 4 tires and hopefully a real spare and steering wheel and whatever other things. If I make 0 cars, I don't need any batteries. On the other hand, there are fixed costs. If I make 1 car or 1,000 cars, I still need that spot welder and the big welding system. I need the paint booths. I need the tools and the machines. That might be my fixed costs. And then I have mixed costs, which are a combination of variable and fixed. And I start looking at things, well, maybe my utilities, my electricity. I'm going to have a base rate, plus I'm going to have additional costs when I have higher volumes. So let's break it down a little bit more. We start talking about variable costs. Changes in total is directly proportional to change in activity. So when we start with $0, well, we have 0 activity. And then we have, when we accelerate, we produce 1 unit. It has a certain level of cost, and typically fairly constant. We have the costs that go with that as we rise, every additional unit, a pretty fixed amount. So we think of making soda, Coca-Cola, Pepsi. We have sugar and direct materials to make the soda. And if we don't make any soda, we don't use any sugar or high fructose corn syrup, unfortunately, to go with that. Then we look at our fixed costs. They do not change in response to a change in activity volume. The average cost per unit is going to be affected, but the fixed cost itself is not. So we're going to see the fixed cost flow. And you can see here, it doesn't change. No response in the short run. We'll talk about we'll have a relevant range to work with, because sometimes your fixed costs, we might eventually need to get another machine if we get to a higher volume and we get some other things to add. But bottom line is no real change as activity increases or decreases within a certain range. So we've got a machine to bottle the soda. If we're bottling 1 bottle of soda or 10,000 cases of soda, we still need a machine to do the bottling. Then we go ahead and look at our mixed costs, and they contain fixed and variable elements, or they also call it sometimes termed as semi-variable. So there's a fixed portion associated with that, and there is a variable portion associated with that. So there's a mixture of that. If you go to U-Haul and rent a truck, and you might get it for $19.99 a day, but then they're going to charge you 14 cents a mile or whatever the additional charge is. So that would be considered a mixed cost to go with that. And then we have something called step costs. And the step costs are within that narrow range. Our fixed costs don't change. But what happens if we do go from 50 cases a day to 5,000 cases a day? Well, we're going to have some additional fixed costs because we're going to have to get some additional machinery to do that. So that's part of the step costs that go with that. So they increase the step-like function as activity increases. You have this relevant range that I mentioned earlier, and that's where costs stay relatively constant. But in the step format, you say, well, I need to buy a new machine, I jump a step. If I need some more equipment, I jump a step. Another building to house this stuff, I jump another step. And so the range is important to consider as we go. And then when costs shift, okay, so we shift more fixed, the trends are towards more fixed costs and automation and we're getting lower variable costs, which is typically labor. So if we can be more efficient, and automation and AI are heavy influences on that, we're able to run equipment, we're able to run activities with less and less people. And that is a direction, but the fixed costs that go with that can be pretty heavy. So you start thinking of countries like China that used to just be able to throw people at it because they had abundance of people and they maybe didn't have a lot of machines, but the people made up for that. Now, globally, the machines are starting to take a dominant impact And yes, that does create other types of jobs, but they are different jobs than the basic assembly line because some of these machines can be pretty efficient and pretty effective in what they do. And we have an assumption to make. We're looking at what the primary cost driver, and ultimately it's usually that final unit of output. It's the car, it's the bottle of soda, it's the the box of cereal. Whatever it is that is the ultimate product, we have the cost drivers to go with that. So that is the first segment, and we're going to jump on the same. We're going to do a second segment here, and we're going to be talking about some cost equations. And there'll be a couple of methods of deciding how we can judge those costs and analyze those costs. So let's take a look at the total cost equation. We have fixed costs plus a variable cost times the number of units. So our fixed cost is our base here. If we make 1 unit or we make 1,000 units, we're going to have the same minimal base of equipment that we have to purchase or have to have. Then we have our variable costs, which starts 0 for materials, 0 for labor if we don't make anything. And then we add material, labor, and overhead as we grow. And we have, you've seen the y equals mx plus b, or in this case, y equals a plus bx. B is that slope of the line. And so that's the variable cost line that goes with that. And we have our fixed cost line. We add those together to get our total cost line. We mentioned the relevant range before. It's the range of activity associated that the fixed costs will basically not have to rise. So we talked about that step as well. But the normal range where we expect to operate, and the fixed cost will remain linear. Total fixed costs will remain the same. So here during normal operations, factory space is adequate for Kellogg's. If there's a surge in demand that exceeds the capacity, they might confront a decision to expand in a temporary facility, another building, more equipment. That's going to be outside of the relevant range. So this relevant range, you can see this little line that slopes up, and you're saying, well, normal range of activity, we're over here. But if we have to get into another building and buy another piece of machinery, we're going to have a sharp jump. So, but we're having a range of what we can produce, and we have excess capacity at the lower end, and we have capacity constraints at the higher end. And so there might be some more marginal costs associated with that as you go, or as we go. Then we take a look, and we have the accountants look at a linear relationship, where the economists look at something called a curvilinear relationship. So we use that straight line a lot in accounting, where the economists, and usually a little more accurate, frankly, curvilinear cost pattern that goes with that. Now let's talk about variable costs. Variable cost per unit, you say, why is this graph going up? Well, the variable cost per unit is the same dollars in materials or labor for every unit. So if I'm using a 64-ounce jug of soda, and I'm going to go ahead and say I've got 64 ounces of carbonated water, and I got 2 ounces of orange juice, Mountain Dew, or high fructose corn syrup. I got 3 ounces. And caffeine, I got a dash of caffeine or whatever other flavors, coloring, phosphoric acid, whatever that goes in. All those are a constant cost relatively. So maybe I have 38 cents in materials for all those chemicals, all those liquids, all those flavorings that are going in. And I make 2 of them, I'm up to 76 cents. So constant per unit cost, even though my costs are going up as we go, every time we increase producing an additional unit. Now, our average cost is a little different, because our average cost based on, say in this case, per customer, what's the cost of serving a customer? Well, if we are making more, the average cost decreases as the number of units of product increase. And finally, we have a couple of types of fixed costs. We have committed fixed costs or capacity costs necessary to maintain the current service or production or projected level of capacity. And then we have discretionary fixed costs or managed fixed costs, and they're set at fixed amount each period by management. So that's a standard that we use, saying here's our fixed costs, and it can fluctuate, but management kind of dictates where that's at. So let's go ahead and jump into calculating cost estimation. And we're going to use three different approaches. We're going to focus on something called the high-low method, which you want to know how to do. But we'll talk about a couple of other methods to go with that as well. So we want to determine the relationship between activity and cost. And we're going to identify variable cost and fixed costs. And we're going to identify elements with mixed costs as well. So we're going to do an analysis to figure this out. So fixed costs, mixed costs, variable costs. The three methods, I mentioned the high-low method we'll emphasize, but there's also scatter diagrams or scatter plots. You see a bunch of dots kind of in a consistency, and you kind of match a line into it and say, yep, here's where the line fits, and this is going up as we make more of this stuff. But the most accurate actually is a statistical tool called least squares regression analysis. So with least squares method, again, that's not going to be our focus. We're going to actually be needing to do some calculations on high-low. So let's take a look at the high-low method and determine how do we figure that out when we're analyzing costs. Well, bottom line is if we know what our number of units we produce and the cost to produce those units are, and maybe we have 4 or 5 lines that say we produced 100 units, it cost this, 200 units that, 400 units that, 500 that, 700 that. Our high and low is 100 units and 700. And then we'll have costs associated high and low with those costs. We'll calculate the difference and we'll be coming up with a variable and a fixed cost to figure that out. So we subtract the total variable cost from the total cost and we get total fixed costs. So you saw that chart, we had the fixed cost, we had the variable costs to go with that. And when we had that combined total cost, if we deduct the variable, we're left with the fixed. So total cost minus the variable cost per unit times the number of units is going to equal our total fixed costs. So here we have 4 months that we're analyzing. And we're Kellogg's, we're making cereal. In January, we made so many boxes for a certain price. At February, we made so many. In March, April. And you look at what's the high number? 11,600 boxes for $31,600. And the low number, 8,600 at $25,000. In the numerator, we're going to subtract the costs. So we're looking at dollars per unit. We're going to put dollars in the numerator. So 31,600 minus 25, the high and the low. And the units in the denominator, the 11,600 and the 86. If we subtract the dollars, we subtract the units. In this case, we get out $2.20 per unit. So that's the variable cost associated with the units. So how do we get the analysis here? So we're looking in January, our variable costs were $220 times the number of boxes we produced. So if we go back here, we see we produced 8,600. We multiply that 8,600 by the 220, and that's the variable cost. And for March, we multiply that 11,600 by the 220. And we're going to come up with the amount per box. And you see that, whoa, we have the fixed cost associated with that. We're seeing the difference. We're solving for A, which is our fixed cost, the total cost minus the variable costs. And we get a consistent number. We have 6,000 in variable costs. In fixed costs. We have 8,600 times 220 as our variable. We have 11,600 times 220 as our variable. Our total costs are going to be the 31,600 or the 25. And because we already use these numbers, that's what's going to be, will be consistent with our fixed costs. And we'll just take a quick look at the high-low estimation. We see that this isn't quite a scatter plot, which we'll see in a couple of minutes, but we have those 4 points on the scale of what we did. So we had the high volume, the 12,000. We had the lower volume here, and then we had the costs associated, and we just basically do a straight line between the two. And in that analysis, we're saying, okay, here's our cost equation. Y equals mx plus b. We have our variable costs times the x plus the fixed cost, and that is our graphing equation. You can make a graph out of that, which we did. We'll take a quick look at a scatter plot, scatter diagram. We have a whole bunch of dots. Now, we probably will throw out some of the extremes, but we will have a whole bunch of dots here. And we can actually draw a line here. Relatively, it says professional judgments required. We can get a pretty good line seeing what our cost factors are based on volume. And that gives us an indication. Again, these we throw out the isolated cases that are at the extremes. Finally, we have our least squares regression method in solving. And this is a cost estimating equation. And you can use all kinds of statistical software to do that. SPSS, we can use Excel to do that. There are a number of calculators that can handle that, math calculators, and other computer programs to do that. So the tools are out there. We can do a least square regression. And with the least square, that's the most accurate. It draws the most accurate line based on all the data points. And that's the ideal, is that you want to be as accurate as you can. Although the numbers in managerial accounting are never perfect, but they're best estimates of what we're doing. And the least squares beats the high-low method, hands down. Again, statistically, it is a tool that comes up with some pretty accurate data. Again, we're going to be focusing on the high-low method here because that's the easiest quick analysis that we can do. And I keep telling you, if you can do four-function math, you can do accounting, add, subtract, multiply, and divide. Well, we're going to be using that high-low method because it's adding, subtracting, and dividing, and we're in good shape. Simple regression, multiple regression, as actually multiple regression has even better facets to go with that. When you have two or more variables, you need to use multiple regression, multiple products, multiple analyses that go with that. And you want to be careful because sometimes a non-linear relationship may exist. If you recall, we use the term curvilinear, and the economists like to do that, and sometimes the accountants get to do it too. But we look at the relationships, and there may be a variety. You start saying, wait a minute, I've got my variable costs that make sense. I got materials that make sense. But what happens if I have a little bit of overtime? Well, that's going to distort the average labor cost associated with each unit because it'll raise it because I got to pay my overtime. So those are things that may affect the pricing and the analysis to go with that. So we'll cut off here for now. And we have one more video for module 15 that we will execute. Hopefully you enjoyed this one and learned and will continue to learn.